In this video, we'll look at naming covalent compounds. So we're just going to start with an example so we can see. So we'll do SO2. So the first element, you're just going to use its name. So that would just be sulfur. And then we have two oxygens. So we're going to use the prefix di to show that we have two oxygens. And instead of writing dioxygen, we're going to write dioxide. So dioxide. So this "ide" is what happens to the second element in your formula. So sulfur dioxide is the name of this. If you only have one of the first element, then you generally leave the mono off because we assume that there's just one if there's nothing in front of it. So the prefixes are mono, di, tri, tetra, penta, hexa, and so forth. You could go higher than that. Often we don't see that. So mono being 1, di is 2, tri 3, tetra 4, penta 5, and hexa 6. So we can indicate how many of a given atom we have by using a prefix in front of it. So for example, if we had this molecular formula, we would call this dinitrogen and then pentoxide. Now notice I didn't say pentaoxide. The O and the A's are generally dropped if you're going to have two vowels in a row. So instead of pentaoxide, I have pentoxide. The I's will stay the same. So di and tri never change, but mono, tetra, penta, hexa, that A or the O on the end will be dropped if you would have two vowels in a row. So let's look at another example. We could have here sulfur trichloride. Now when you have an element that is in a 1-to-1 ratio here, so we have HI, we usually don't use the mono for either one. So this would just be hydrogen iodide. Okay, so when it's a 1-to-1, you don't need a prefix for either, and it's assumed that it's 1 on each one. So we'll just do a couple more examples. So here I have carbon tetrachloride. So remember I have the "ide" for the second element, and then this A stays because I have a vowel but then a consonant. So because chloride starts with a consonant, I can just leave the A there. So it's just the vowel that would make you drop the A or the O. We could also go the opposite direction. So if we had dihydrogen monoxide, we would have two H's and one O. So that's water. Water is the common name, but the systematic name is dihydrogen monoxide. Because water is used so commonly, we don't really call it that, but that's the specific name. So again, going the other direction, we could do dinitrogen trioxide, and see when I have this trioxide, I do have the I and the O in a row. So for di and tri, you leave it when there's an I there. So it tells me that I have two nitrogens and then I have three oxygens. If I had, for example, carbon dioxide, I would know that I have only one carbon because there's no prefix in front of it, and then I would have two oxygens. So the formula would be CO2.